So here we're told that a sequence of numbers is defined by this rule. So the first term is 3, second and 5, and every term beyond that is the product of the previous term. So which means that A3 is product of A1 times A2, and in this case would be 15, so on and so forth. They tell us AN is T, and N is some number greater than 2. Question is, what is the value of AN plus 2 in terms of T? So that means AN plus 1 would be AN times AN minus 1, AN minus 2, so on and so forth, all the way to A1. So these are the previous terms. Now, AN is AN minus 1, AN minus 2, all the way to the first term. That is exactly this chunk here. Now, we're given that this is equal to T. That's T, so AN plus 1 would be T squared. They're asking for AN plus 2, so AN plus 2 is AN plus 1, AN minus 1, AN minus 2. It's good to write descriptively. And we know that AN plus 1 is T squared. What about this term? Well, that is same as AN plus 1 as well, as you notice here. So it's product of T squared times T squared, which is T to the 4, and that is answer choice D. So in this question, we're given the first and second term, and actually for this particular problem, we don't really need to know what the value of these terms is. It's actually irrelevant. But they do tell us that the terms from second onwards, meaning the third term, is the product of the previous two terms. Same thing, fourth term would be the product of the previous three terms, and so on and so forth. And what they do is they tell us that the nth term is T, and they want to know what is the value of the n plus second term, meaning whatever the position is AN, next term would be AN plus 1, and then after that would be AN plus 2. They want to know what that would be in terms of T. So if we look at these terms, and let's say this is AN plus 1, and AN plus 2, AN would be the product of the terms, all of the terms that are prior to AN, and we're given that AN is T. So this product itself is equal to T. Now I can also now write A sub n plus 1. So this term would be the product of all of these terms, AN and the terms prior to that. So it's going to be equal to AN times T, because remember, T is the product of these terms before AN. And now we can also write A sub n plus 2. First I'm writing all the relationships. So AN plus 2 would be the product of all the terms that preceded, which would be A sub n plus 1 times A sub n, and then all these terms prior to A sub n, which we know the product is T, because that's what we are given. So these are the relationships, and we just have to express AN plus 2 in terms of T. This is T, and I can also replace AN with T here, so A sub n plus 1 is T squared. So that means it's T squared times T, which is T to the 4, and that's answer choice D. So here I'm going to do the same problem with the plug-in approach. So we're given A1 is 3, A2 is 5, we're given A sub n is 2, T. So we need to pick a value for n, and we're given the condition that third term onwards, that all the terms are equal to the product, the previous term. So I'm going to pick n is equal to 3. So A3 is T. A3 is now product of A2 and A1. So that's going to be 3 times 5. And based on the problem, since I chose n to be 3, they're asking for AN plus 2 in terms of T. So n is 3, so we're looking for the A5th, the fifth term. And the answer that would match with A5 for T equal to 15 would be the correct answer. So a fifth, so I'm going to compute a4. A4 would be, let me actually write down these terms in sequence. So a4 would be the product of the first three terms, which would be 3 times 5, then times 15, which is a3. So it's 15 times 15. A5 would be the product of the first four terms. So that's going to be 3 times 5, that's 3, this is 5, this is 15, and then a4 was 15 times 15. Notice this is really just 15. And I'm leaving it in terms of 15 because that's what t is. And you'll notice that this is 15 to the fourth. So you just have to replace t equal to 15 in the answer choices. And you'll see the answer choices are 4 times 15, 15 squared, 15 cubed, 15 to the fourth, and 15 to the eighth. And it matches with 15 to the fourth, which is indeed the correct answer.